All right, part three, here we go. First of all, you got to complete part two. So, yep. If here you are, you're on part three. This is the section you should be on. That means you have completed up here. Well, you've obviously completed all this. Basically, you did part one, and then last class you did part two, which is oh my gosh, yeah, right here. Yep. And now you're on part three. All right, let me just get right to it. So you got to click on this thing first. So you click on this thing. Yay. All right. Opens this on up. Now hit start right there. Now you're going to click on the bot. Oh, well, you're just going to go to layer mode, right? Let's see what it says here. Layer model. Yep. Layer model right there. Click that. All right. Hit start sunlight. You're going to have to do it. Now, what is the temperature in Fahrenheit? Why do you think this is? All right, so if I'm looking right here, let's change this one to Fahrenheit. Oh, wait a minute, I gotta change it like that. Sorry. So, um, let's take a look here. So, why do I think this temperature is the way it is? Because that temperature is, Ugh, probably need another jacket. Okay, that should tell you what the temperature is like. Now, why do I think it is? Because there's no greenhouse gases or anything really trapping in the sunlight. So I think this, I'm sorry, not the sunlight, the infrared light. So I think the sunlight is coming in, no problem. But I think the infrared energy is being transferred right out. So the infrared energy. So the result is sunlight's coming in, but all the infrared energy, heat is leaving. All right. Play around with the solar intensity and surface albedo. What can you tell me? So, yep, that's these two right here. Play around with them. Okay, what happens when we bump that up? I don't know. All right. Oh, yeah, that happened. All right. Now, lower that, I guess. All right. Looks like you need a minute or two. There's like a delay. Now play around with that. Oh, wait, that got a lot hazier. And then if I drop it like that, oh, we got a lot clearer. And I put it like there where it was. Okay. Yep. So play around with them. Tell me what you get. Add one absorbing layer. So as add an absorbing layer, I go up like that. Oh, gee golly whiz. Oh, look what happened to temperature. Oh, cool. All right. And oh yeah, that's in Fahrenheit. That's the way I like it. All right, because we're here in the United States, although Celsius might be easier. Um, what do the visible and infrared photons do? Oh, okay. So, so the visible go right through, but then the infrared kind of like rebound off that glass layer or absorbing layer. It's almost like a greenhouse in a way. So, let's see here. What do the visible and infrared photons do? Visible go right through. Infrared, some of them do not go right through. They rebound. All right. What is the temperature now, and why do you think this is? Okay, temperature is right there. Yep. Why do I think that is? Because more of the infrared photons are getting trapped inside. What is the temp? So let's go crazy and add the maximum number of absorbing layers. Oh, I like this guy. Wow. All right. 1, 2, 3. Yeah. Let's go cray cray. All right, so the sunlight still goes through all of them, and then dang, look at all of them here. They're like the bottom layer, it's like got all the infrareds, like a lot of them are trapped, and then there's a little less for the second layer, and then the third layer, it's got less, and then the top layer doesn't really have too many infrareds. And oh my gee golly whiz, look what's happened to the temperature. Dang, I wish my bank account rose like that. So, we're looking. Oh wait, I got the wrong question. I got this one here. At what glass layer do you see the most protons? Gave that answer when I was talking about it. What is the temperature? Still going up. We'll get to that one in a second. Um, And why do you think this is? Alright, so I think it is because a lot of these infrared are getting trapped near the surface, alright? And as far as the temperature goes, it's still going up. Um, so I think the sunlight, visible photons come through, and I don't think the infrared can leave. That's still going up. Wow. Alright. Glad we don't have it on slow. Alright, we'll come back to that guy in a minute. Alright. Um, relate this experiment to a car and greenhouse gases. Well, for one, I've always heard you shouldn't leave your dog or children in the car on like a sunny day with the windows up. I could probably relate that with this. And as far as greenhouse gases, a greenhouse, like the glass planes trap heat, kind of like greenhouse gases trap heat. So, yeah. Yeah, that's what I like about that. So, yep. Let's see that temperature if it's still there. Yeah. All right. As far as questions go, in a paragraph, summarize how the greenhouse gases affect the Earth's atmosphere during the ice ages, the year 1750 and today. So, which one of them had more greenhouse gases, and which one of them? What was that temperature like? Which one had less greenhouse gases, and which one was? How was the temperature like? Um, predict what would happen to the Earth's temperature if there were no greenhouse gases. No greenhouse gases. What do you think the temperature would be like? Guess from the moon. You know, go back and adjust the greenhouse gas concentration level to none and test your prediction. Were you correct? Was the Earth's average temperature with no greenhouse gases? All right. So I think for that one, I have to go over to here to the photon. I'm sorry, to the first one. Yeah, start sunlight. Um, so no greenhouse gases. All right. And then I'm going to change that to Fahrenheit so I can read it a little better. Yeah. All right. That's pretty cold. All right. Um, yeah. So, yep, my prediction was correct, or maybe yours was too, or maybe yours wasn't. All right. Go back and adjust. So, what would happen if the Earth's average temperature, if the greenhouse gases increased? So, if the greenhouse gases increased, I'm going to say that the temperature would do something as well. All right. Uh, let's change the greenhouse gas concentration to lots. All right, got hazy. Also, the temperature is okay. We're cooking. Oh yeah, it's like a Nelly song. It's getting hot in here. Keep on all the clothes. All right. Yeah. So that here. Yep. Uh, describe what happens to Earth's average temperature. Good. Identify two natural and two human processes that might increase or decrease the amount of gases in the atmosphere. For this one, you're going to have to use your brain, look it up, do all that sort of stuff. So, or, I don't know, bribe me with maple syrup. So, all right, peeps, my best.